I do want to thank the International Wood Culture Society for making this all possible. Now, you do realize you're going to hear a talk on termites. And I assume most of you have had some dealings with termites. And simply put, they like wood, right? So this is an appropriate talk. In my talk, I will talk about the order Isoptera, at least give you the old evidence. I will give you new evidence. There's new evidence on termites you might find interesting. I'll talk a little bit about how termites are classified. Of course, I'll mention their biology and ecology. I will talk on their economic importance. I will mention control past and future. And I'll finish off hopefully with some statements about a more healthier and productive environments. The question I get from kids, in California especially, is why are there termites? And that's a good question. And this slide here shows a wonderful sunset from Tanzania, another one of the lovely coastal shots. Please remember the source of all energy on Earth is the sun. And because of the sun, it energized the Earth's surfaces. And that went on for many billions of years. But then a miracle happened. It's called photosynthesis. And through that miracle on Earth, probably one of the first miracles on Earth, light energy is turned into basically cellulose, which is made up of sugar. Now, what you have to think now, when you have just uncountable tons of sugar laying around, you're going to attract something. And one of the first organisms to attract to this, of course, are termites. The ancient history of termites goes back. Let me see if I had another slide in here. Does this go back? All right. So how old are termites? They're at least 100 million years old. They're in, at least for a long time, they were in the order Isoptera. Now here we go, jumping into Greek. What does Isoptera mean? Basically it means same wing. And actually before that time, termites were named in the 1800s along with Linnaeus helped to name them. But for a long time, termites were considered white ants. You might remember that common phrase used. Oftentimes in the old literature from Africa, you hear the term white ants. They aren't ants at all. They're a very different insect. More recently, molecular research out of England suggests all a termite is a social cockroach. Now, I know for some of you that's going to be new information to you, but yeah. And I go to cocktail parties in North America, and it's okay for people to talk about having termites. Not many people mention at cocktail parties they have cockroaches. But the fact of the matter is, termites and cockroaches share a common ancestry based on their DNA. Remember, in the world of biology, we look at it through different lenses. So depending upon the glasses you wear, you see something very different. In today's world, DNA is very important. So basically, termites are social cockroaches. Now, there's some consequences to that, and we'll talk later on that. But for the most part, most of the termite diversity that we see today in the world, you might wonder, how do they separate all that apart? They basically look at the wings of the kings and queens, mostly the new kings and queens that emerge, or the teeth on the soldiers. Those are the important characteristics of separating all the termite biodiversity out there. Now, we have at least 2,600 recognized species of termites in the world. You might think that's a lot. Actually, by bug terms or insect terms, it is not. If there is a God or Buddha or Allah in the world and he is made in their image, it would probably be more like a beetle. There's more beetles on Earth than any other named life form. There's at least 300,000 and counting. So we have that much termite biodiversity in the world. It's actually simply put into 7 families. All those families are represented here in Africa. The more primitive families are at the top, the more advanced ones are at the bottom. And yes, of course, the greatest termite diversity in the world exists in Africa. Over 1,000 of the described species, that's almost probably a good 40% of the termite described species, come from the African continent. Yes, Africa is the mother and fatherland for termites, as it is for humans. We're very blessed to have this continent here on Earth. Termites are social insects. They have castes. What I mean by that, they divide up the labor that the colony does. So, and most of you know these common terms. They're workers, they're soldiers, they're reproductives. The interesting thing about termites is it's okay to be male and female. You know, remember in the wasp and the ant world, it's mostly mom and all her daughters. In the termite world, it's okay to be a male. It's also okay to be a female soldier. So it's truly one of the most democratic and representative life forms on Earth. Termites have a very, very flexible life cycle, probably one of the more complicated amongst terrestrial animals. They start off as an egg, they hatch into several larval instars, and then they transform into a worker, soldier, or reproductive. They're very flexible. As for many of you out there who've had to battle termites, we'll talk later about their economic importance. They're very prolific. Some of those termite mounds you'll see can contain millions of individuals and live a long time, literally decades. Queens can live for a long time. Most people think of insects living a few weeks or a month. That's not the case. Termites can go for decades. Global impacts. Here's some examples here of the impacts of termites around the world. Forests in North America. This shows a bark beetle killed trees. Yes, bark beetles will kill trees, but you can bet when the bark beetles are long gone, then it's the termites' turn to recycle that. We also have a photo from Pakistan. Yes, desert areas have many, many termites. You don't see them during the heat of the day. I assure you, if you come out at night, wet the ground, put a piece of wood on there, they will come. They're very important to savanna and grasslands. You have plenty of savanna grasslands here. This image shows in northern Australia, Darwin. If you get a chance to go there, they have impressive termite mounds. The places in the world that have the best termite mounds are, of course, Africa and Australia. There's a termite mound in Australia that allegedly is 10 meters in size. Wow. Haven't found one yet. Maybe someday I can look here in Africa for something that size. And of course, here's a snow scene from Verbier, Switzerland. What that represents is, even though there are no termites in Verbier, Switzerland, they contribute greenhouse gases to the world's ecologies around the world. Termites are the major producers of many gases that our atmosphere share. Termites express themselves in many, many different ways around the world. There's a tree up to my far right. That comes from the Nasuta termites from the Caribbean. They make these big mud balls. You might see those here in parts of Africa. There's another big termite mound. That's a big one from Darwin. Darwin's an amazing place if you get a chance to go. Most of the termites in the world are subterranean. To my lower right, there's a bit of carton nest from a subterranean termite. You rarely see their nests. They're hidden in the ground. And there are many, many drywood termites. They don't require soil contact at all. In many parts of the world, in a dry building like this, you can find drywood termites. They don't require soil contact. They have no need of freestanding water because they use metabolic water when they digest cellulose. That central image in the middle of this photo is Mastotermes darwensis, considered the most primitive termite in the world. It exists in Australia and Papua New Guinea. Termites contribute many, many factors to the world's ecologies. They recycle wood. If it wasn't for termites, think how deep we'd be in trees and grass and cellulose garbage. And by the way, most garbage streams in the world are made up of cellulose. Plants that we chop up or throw out, or newspapers. They recycle soils. Many soils in the world don't have earthworms. They have termites to tunnel through the soil, to aerate it, to make it permeated with water. They added, I already mentioned how they add gases to the atmosphere. They fix carbon to the soil by their droppings in their bodies. And they add to a global pest control industry. And by the way, this is a queen termite, Termites, from Pakistan. Now, the economic importance. All right, this is the way I see it. Most people in the world, if you go by UN stats, they live in cities. That's called urban intensification. Anytime you put a bunch of buildings together, you're going to attract pests. And if they're made of wood, you're going to get a bunch of termites. That's a growing situation around the world, particularly in Asia. I spend more and more of my time in Asia because more and more people have the resources to live in cities. If they use wood, they're going to attract termites. The other big intensification is agriculture. We heard some of that earlier today. This slide shows intense cotton production in Pakistan. In the middle is a Sahara scene. Then that big date palms from Pakistan and Morocco. We have agriculture with grapes in South America, and then we have maize here in Africa. If you wet the ground and put something green in it, you're going to attract something. Normally it's termites. Oil date palms are a big deal in Indonesia right now, funded by the World Bank. They're running out of the best soil, so they're using marginal soil, and the termites are taking advantage of it. Why? Because if you take an exotic crop and put it in an exotic land, it sometimes struggles and becomes more vulnerable to termite attack. The other big issue I see is invasive species or invasive pests. Termites are on the move around the world. In the center of this picture, I have some small termites. That's Termites. This particular one is Termites formosanus. That's a hitchhiker on most continents right now. What's it do by? International commerce, military, tourism, storms. Yes, storms. We have a big problem right now with the Nasuta termites problem in South Florida. It's being pushed around by hurricanes. Get used to it. What do we do about that? Humans like to have things their way. We're control freaks. So we're in competition with termites. In the past, what would we do? We use chlorinated hydrocarbons. You might remember some of this stuff. DDT and chlordane, does that ring a bell? And the reason why we use them, they were cheap and they were long-lived materials. Because of international treaty, and I hope people here have heard of the Stockholm Convention, which banned the use of these materials, and I'm seeing some heads now, thank you. So, by the way, you know what the #1 pest system that they use chlorinated hydrocarbons on? #1, you guys should know this, malaria and mosquito control, right, DDT. You know what #2 on the list was? Termites. Aha. So the UN has worked hard to stop the production and use of these materials around the world. I'm hoping that that's reached most of Africa, but you know, there is a big exemption. That's DDT for malaria control. Unfortunately, sometimes people will take DDT that they're supposed to use for malaria control and they use it for termite control. That's kind of against the international treaty, but you know how human beings are. Now, which brings us to this group. This is called the GTEG. Now you're going to go, huh? GTEG stands for the Global Termite Expert Group. It was convened about 13 years ago at the request of the United Nations. The United Nations has been tracking termite control and the use of POPs for a number of years now. And this is an international group. They haven't met since 2005. It looks like a lot of the group members are retired or dying or we've run out of funding. But we did have this group meet 2 times, once in 2000 and once in 2005. I don't have a pointer here, but this group of 20, there were at least 4 that represented Africa. North Africa, East Africa, not Tanzania, was from Kenya, and West Africa, and we had several from Ethiopia. What this group was put together, the UN wanted to get the world weaned away from use of persistent materials in the soil for termites. You do realize the problem with putting nasty things in the soil for termites, it ends up in our water tables, right? And that poses a problem. And this was, actually it was a joint sponsorship from UNEP, the United Nations Environmental Program, and FAO, Food and Agriculture Organization. I was proud and honored to be one of that 20-member group. We haven't met since 2005, and that has a lot to do with funding. But the fact of the matter is, the mechanism exists, and there are some inventories. For those of you who are interested in inventories, I have several of these UN documents that came from a website. I'll show you where the website is. It's still active there. What's not active is a cohort of experts actively doing research under the UN flag. Maybe someday we can get some of our policy members to reinvigorate the group. The fact of the matter is, there are thousands of different chemistries that have been developed principally for use of termites around the world. Sometimes we use other methods. This is a very busy chart, but just trust me, there are many, many, many active ingredients. The tendency now in active ingredients around the world are to be short-lived. So when you get your termite control in your home, it's not like in the old days with chlordine where you could get a lifetime or 40-year guarantee. It's more like 3 to 5 years. We design them that way so they don't hurt the ecosystem. Please remember that. Now, there are many, many non-chemical methods to manage termites. This comes from one of the UN websites. On your computer, when you have time, you can go look at that at your leisure, because I know when I'm done with this talk, there's going to be a bunch of questions about termites. I know it's coming. There was an attempt, though, actually up until 2007. Does anyone know what the GEF is, the Global Environmental Fund? Yes. Okay. There was an attempt at the United Nations level to produce a global project to work on all continents with termite controls, but we couldn't get the ministries of agriculture to buy off on it. We actually got the GEF was willing, I was on that committee, the GEF was willing to kick in money, but we couldn't get the participating countries to match the funding. That's just the politics of the game. But I wouldn't be surprised if there was interest in this region, if termites are an issue. I know Nairobi is a big regional headquarters for UNEP. There are some people there who might lend an ear to this, but it'd probably have to come from pretty high up in the ministry. The other thing I'll mention is new innovations. I mentioned a little earlier about the use of molecular genetics. We have dyes, these special dyes we can dye termites. We have hydrocarbons. And what all this technology means is we're going to get new species. That's just the way academics do. We get our merits and promotions by naming new things. I personally don't do that. My other colleagues do. And when we're not naming new things, we're describing their ecology, particularly how they forage. I think that's good stuff because it'll lead to baits. Someday we'll replace a lot of these soil drenches with these very targeted baits. We already have them in some parts of the world. We need more of them. And we have better detection aids. Now, the difficult part about termites is we don't see them because they hide well in buildings, especially. In agriculture, it's a little different because you have 10,000 hectares to look for them in. But there are a growing number of detection aids. They're not cheap yet, but they're out there. And we do have a number of growing non-chemical alternatives that people are trying in different parts of the world. These are just some of them. Electrocution, liquid nitrogen, heat. Mentioned heat earlier in the earlier talk. We need more of these innovations too. Before I end here, and I'm almost done here and I'll take questions, I want to mention some of the challenges that lay ahead for us. Of course, global warming. As the planet warms, there's a lot of consequences to that. You heard some of them earlier today. Regrettably, as the temperature warms, it looks like some of our termite pests are increasing their range. Especially in, I know there's been a lot of funding has gone into the Sahara Desert to the north to try and reclaim those soils back for agriculture. With mulching, it's had mixed success, but with global warming, it's going to make the demands even greater because it's going to force invasive termites to expand their range. As I mentioned before, international shipping trade and air travel has pushed termites into new areas, particularly Termites. The big difficulty is there's a big move to increase the use of agriculture in emerging economies in the world, particularly for cash crops. Please be careful with putting in cash crops in your areas around the world. If you guess wrong, it becomes termite food overnight. Then the last two things, of course, is we have to protect our water and air quality. Sometimes the nasty things we put in the soil halfway around the world end up at the North Pole in polar bears. They've dissected their livers, trust me, it's there. And then we have to do all this on limited world economies. We just have to be very careful in spending money around the world. Now, I mentioned two websites. I'll leave them up there. The first one is the UN website. It's still there. That's where all these documents came from. And that second website is my website. If you're interested in the international one, go to the UN. If you're interested in what might happen in North America or heavy urban areas, then go to the second one. And I thank you for having me today.